Hey students, it's me, Mr. Fitz. No, really, it's me. Some of you requested I become a wolf in my video. Best I could do is a fox. So there you go. Um, I wanted to talk briefly about coordinate geometry and the reason, and coordinate proofs, for example. And the reason is, if we think back to our GeoLantern activity, right? A lot of you wrote on your GeoLantern assignments and you created eyes just like these, which are isosceles triangles. And a lot of you wrote that they're actually equilateral triangles, and they're not, because if they were, then all the sides would have to be the same length. How could we prove something like that? Well, now that we know distance formula, you could actually calculate the lengths of these line segments using distance formula or Pythagorean theorem. So I'm going to take you through an example of a coordinate proof, and hopefully this helps. So let's take a look. So here's what we're trying to prove. We're trying to determine whether the parallelogram EFGH is a rhombus, rectangle, square, or none, and we have to explain. First of all, on the handout, I believe you have the coordinates of EF, G, and H, which I will go ahead and graph it, and that's step one. So which I've mentioned in class, to really develop a good understanding of something, you should be able to explain something visually by graphing it. You should be able to explain something mathematically or algebraically, if you will, using our algebra skills and our math skills. And then you should also be able to explain your thinking in words. So that's going to be the fundamental thing we need to actually get a handle of in coordinate geometry, so coordinate proofs. So let's take a look. So the first step is graph the problem. And these were the coordinates that we were given for E, F, G, and H. So I've graphed it. Now, looking at this, it looks kind of like a rhombus. But I need to prove that. And they've told us it's a parallelogram, so we don't necessarily need to prove it's a parallelogram, but I'm going to prove it is anyway. So let's take a look. So in order to prove something's a parallelogram, we can pick any one of these three things. So if we're looking back at our family tree, we could prove that the opposite sides are parallel, right? Using slope, if they're the same slope. We could prove that the opposite sides are congruent using distance formula, just by seeing if they're the same length. And we could also prove that the diagonals bisect each other, meaning they cut each other in half, these diagonals, if they share the same midpoint. So I'm going to pick one of those to prove it's a parallelogram. I think I'm going to use slope because that's my favorite calculation of the three. And so it gives you choice, right? You don't have to do all three. If you really like midpoint formula, prove that the diagonals bisect each other. And then we can go and prove that something's a rhombus using distance formula if it has all four sides of the same length. We could also prove that the diagonals are perpendicular using slope. Remember, if they have negative reciprocal slopes, then they would be perpendicular. Here, if we have to prove something's a rectangle, we can prove that the parallelogram has four congruent sides if four congruent angles if these are all perpendicular. So we would use slope to figure that out. Or you could prove that the diagonals are the same length. So hopefully my iPad doesn't die. So I'm going to go ahead and prove this is a parallelogram mathematically now. I'm going to use slope. And so I'm going to calculate the slope of EF, this line segment. And again, I'm just going to stack my coordinates, which we went over, and think about my change in X and my change in Y. My change in Y is 3, positive 3. My change in X is positive 2. So this is a slope of 3 over 2, right? Up 3 over 2. What's the slope of GH? So that's this line segment here. So if I stack my coordinates, that's a negative 2 for my change in X and a negative 3 for my change in Y. Negative 3 over negative 2, well, that's 3 over 2. Okay. And then if we look at the other two line segments, FG and HE, which are these two line segments, I can see that they have a slope of negative 3 over 2. All right, well, that tells me I have two sets of parallel sides, right? I have two opposite sides that are parallel because they have the same slope. So I've gone ahead and proven that this is a parallelogram mathematically. Now, it's also definitely not a rectangle or a square. How do I know? Well, we would have to have some right angles here. In order for them to be right angles, they would have to be perpendicular. So For example, if this were 3/2 and this were -2/3, remember if we flip this and change the sign, then that would be a right angle, but it's not. So clearly there are no right angles here, so it can't be a rectangle or a square. It still could be a rhombus, so that's something I need to look at. So in order to prove a rhombus, what do I need to do? I can either prove that the parallelogram has 4 sides that are congruent or diagonals that intersect to form perpendicular lines. Looking at this, it looks like that these are perpendicular. So that would be pretty easy to prove, just calculating the slopes of these 2 line segments. And this one would be a 0 slope. This would be undefined because it's vertical, and therefore that these are actually in fact perpendicular. So I do know it's a rhombus, but let's go ahead and calculate the distances of all the sides. So I'm just going to use Pythagorean theorem here. So if I figure out the length of this side, I know this is 2 and this is 3. You could use distance formula, that's fine. And then so if I just use Pythagorean theorem, 2 squared plus 3 squared equals c squared. So 4 plus 9 equals c squared. 13 equals c squared, take the square root of both sides, and lo and behold, you have this line segment equals radical 13. You can just leave it as radical 13. You don't need to simplify it anymore. And there you go. And then look, if I do this 4 different times, I'm going to get 4 of the same side lengths, radical 13. So what does radical 13 actually equal? Let's see. Radical 13 is about 3.6. So that makes sense, right? Because that's the hypotenuse. It's got to be the longest side. So this length is about 3.6. So if you wanted to round that to the nearest tenth, that's what that would be. But you can just leave it as radical 13. Okay. So that was step 2. I proved it mathematically, right? I proved that this thing is actually a parallelogram and a rhombus. Now what I want to do is use my concluding statement. That's the last step. So what I would say is therefore, and that's what these 3 dots mean, EFGH is a parallelogram because opposite sides are parallel, and a rhombus because, oh, I didn't finish that. Let me finish that up. Because it has 4 congruent sides. So let's go ahead and write that in. And also what I could say, because it has 4 congruent sides. What I could also say is it's not a rectangle or a square because it has no right angles. And then lastly, I would write QED, which is quod erat demonstratum in Latin, meaning I did my work. I proved what I was supposed to prove. Okay, so there you go. Hope that helps. And please let me know if you have any questions. Thank you so much for watching. What does the fox say?